This is the second part of lesson 29, Newton's law of universal gravitation. And here's a more typical problem that you would be asked in this unit. Instead of just asking the force, gravitational force between two objects at a given distance, you can have multiple objects. In this example, we have Io, one of the moons of Jupiter, Jupiter and the Sun. And it says, some interesting information there, says on one particular occasion, the Sun, Io, and Jupiter lined up in a straight line so that both the Sun and Jupiter were pulling Io in opposite directions. Using the information on the chart given, determine the net force acting on Io at this time. So they're pulling in opposite directions, so the configuration must have been like this. Sun must be here. Jupiter must be here, and Io must be there, because it says they're pulling Io in opposite directions. So the Sun is pulling Io in this direction, and Jupiter is pulling Io in this direction. So once you've got a diagram like that, it's actually pretty straightforward. All we're going to do is find the gravitational force between the Sun and Io, and then we're going to find the gravitational force between Io and Jupiter. They're pulling in opposite directions. Then we're just going to subtract those two values, or we're just going to make one of them negative. And once you've got that principle, then it's just a matter of crunching all the numbers. I could set it up like this. I could say that the net force on Io equals to the force of gravity between the Sun and Io plus the force of gravity between Io and Jupiter, if I want to set it up that way. And then this one's going to be 2 over R, or I guess I should say S and I plus G M I S M J over R squared, and just making sure that one of these is positive and one's negative. So I'm just going to put brackets there. This one over here, I'm just going to say is negative. All right, now just before we actually solve the question, and as I said, at this point, it's just a matter of punching in the numbers and getting the right answer. Let's just make a hypothesis as to what we think is going to be correct. Which way do you think Io will be pulled? Will it be pulled more towards the Sun or more towards Jupiter? Well, given that we know that it's a moon of Jupiter, the answer is obvious. It's obviously pulled more towards Jupiter, or otherwise it would be a moon of the Sun, or it would be orbiting the Sun, revolving around the Sun, not revolving around Jupiter. So Jupiter does win out. Why does Jupiter win out? The Sun, as you can see, is, let's see, how many times greater is the Sun than Jupiter in terms of its mass? 30 minus 27 is 3. 10 to the power of 3 is 1,000. So the Jupiter, or the Sun, is approximately 1,000 times more massive than Jupiter. However, it's the distance that's the killer. Io is right next to Jupiter, and it's way, way, way far away from the Sun. So that's what makes the difference, is the distance, even though the Sun is 1,000 times more massive than Jupiter. Okay, so actually, we can plug in the numbers. So let's plug in the numbers. This is going to be, it's going to take a lot of room. So it's going to be 6.67 times 11 times. Okay, what did I say first? First we said, let's move it down here so we can see it. Said the mass of the Sun, 1.99, let's just abbreviate here so we can run out of room, E30. Oh, we're going to run out of room anyway. And Io is E22 divided by the distance between Io and the Sun, which is 7. E 11 all squared. So there's the gravitational force between the Sun and Io. The gravitational force between Jupiter and Io. I'm just going to write it down below. So I'm going to run out of room. And I'm going to put a negative there just to acknowledge that they're in opposite directions. 11 times the mass of Io times the mass of Jupiter divided by the square, the distances squared, the 8 squared. Stick that into calculator, which you need to practice big time, because this is actually a relatively, on your calculator, this is a relatively simple calculation compared to when we get to Kepler's laws and other things in physics. So please practice this on your calculator. It's really easy to make a mistake, forgetting to square something, forgetting the negative. Anyway, once you've done that, you should end up with an answer of 6.35 times 10 to the 22 newtons. Okay. Interestingly, just as an interesting fact, if you're just calculating this top one here, if you're just doing that one, you end up with an answer of, what do you end up with now? You end up with this answer here. 6.35 times 10 to the 22. And then when you calculate in this bottom one, you end up with an answer of 1.86 times 10 to the 19. But your final answer is this. Your final answer is the same as that. Well, that just goes to show you, oh, sorry, did I do that? Did I get those ones backwards? This is the Sun. Sorry, I got those ones backwards. So switch those. The gravitational force between Io and Jupiter is so much stronger than the gravitational force between the Sun and Io that this value here is actually negligible compared to this. As you can see, this is a 19, this is a 22, so this number here is 1,000 times greater than this. So it's really irrelevant, well, not irrelevant, but negligible. Okay, so that is a more advanced example for gravitational force.